Kayla, please.
Jane makes $10.50 an hour and Lee makes $12 an hour. Write the ratio of what Jane earns per hour to what Lee earns per hour.
Question A.
As a fraction, see if you can reduce this without any decimal.
Question B.
As a decimal per one, what would be an appropriate place to round this answer?
Okay. And question C.
In this course, meaningful sentence refers to a statement that demonstrates the meaning of a calculated value. When it comes to ratios, these sentences should feature a reduced form of the ratio of values provided. Write a meaningful sentence using one of the ratios above.
Okay, very good. Thanks. Okay, thanks. So we're gonna answer these three questions, A, B, and C. Okay. The question is, Jim makes $10.5 an hour and Lee makes $12 an hour. So these are the two quantities for us, right? So question A is, write a ratio of what Jim earns per hour to what Lee earns per hour as a fraction. So what do we do? As a fraction, we know we should write it in the form of a fraction, right? So it is going to be what? $10.5, that's what Jane makes, right? An hour. And then $12, that's what Lee makes an hour, right? See if you can reduce this without any decimals in it. How to reduce $10.5 per $12. So at the first, how about unit? Dollar cancel out, right? Now we have a 10.5, we have a 12. Simplify it as a fraction. Have you ever encountered any fraction who has a decimal on the top, 10.5? No. So how to simplify 10.5 out of 12? What do we do at first? Have you noticed this decimal point? Do you like it? No, no, right? 10.5. So at the first, we're gonna try to get rid of the decimal point. By how? How to get rid of the decimal point? 1 digits of the decimal point. In order to get rid of decimal point, we multiply this number by 10. So we'll get a 105, right? However, for a fraction, if we multiply 10 to the top, we have to do it to the bottom as well. Right? So 12 times 10, right? 12 times 10. Alright. And then 10.5 times 10 is 105. 12 times 10 is what? 120. So now we don't have any decimals, right? On the top and the bottom. So 105 out of 120. How to simplify this? out of 120. What is some factors you can think of? Can you think of 5? Can you think about a 5 as a common factor? Or something else? How about we start from 5? What do you think? So if 5 is a common factor, 105 divided by 5 gives us what? Use your calculator. 21. What is 120 divided by 5? 24. So 21 out of 24, do you think this is already in the most reduced form? 21, 24, any common factor? 3, right? So we could use 3 as a common factor. 21 divided by 7 is 7. 24 divided by 3 is what? 8. 7 over 8. What do you think now? Is in the reduced form? Yes. Okay. What's up?
Why don't you choose 10 again?
What?
Why did we choose 10 multiply by again?
Because 10.5 and 12, we're not able to find a common factor. It's not easy. I cannot say we cannot. Well, for me, I would say the common factor for 10.5 and 12 is 1.5. That will give us 7 over 8 directly. You divide 10.5 and 12 by 1.5 directly. That's a common factor. But if we have a decimal number, can you find out the common factor between 10.5 and 12? It's not easy. So that's why we want to get rid of the decimal point. So that's the reason we want to multiply this number by a 10 to to have an integer, right? Then we reduce the fraction integers divided by integer. That's the reason why we have to multiply by 10, right? Because we want to simplify 10.5 divided by 12, right? We want to simplify that. But can you find a common factor directly between 10.5 and 12? It's hard. So that's why we make this decimal number to be an integer, both top and bottom. Then we reduce from there, right? So that's how we get 7/8. Everybody? Question? No? Yeah, this is a very challenging question. If I let you guys do this problem by yourself, some of you guys may feel hard. What's up?
So if it was any decimal, if it wasn't 10.5, if it was any decimal, we would still multiply by 10.
It depends on how many digits after the decimal point. If there's one digit here, we multiply 10. So say for example, if I'm going to give you another question, let you simplify. Say for example, 10.55 divided by 12. So this time, do you multiply by 10 or multiply by 100? You multiply by 100 from both top and bottom to make it 10, 15, 55, and 1200. Then you go from there.
Because that represents hundredths place after the decimal? Okay.
Yes, yes. Because if we want to make this number to be a integer, we have to move the decimal point to the right for 2 digits. So that's the reason we have to multiply by 100 to the top. But if we do this to the top, we have to do it to the bottom, because in order to make this fraction the same as has the same value as the previous fraction. So it really depends. This one we multiply by 10. This one you have to multiply 100 from both top and bottom. Very good question. Any other questions? Okay, question B. Write this ratio as a decimal point. How? Either you use 10.5 divided by 12 directly, or you can use 7 divided by 8 directly. 7 divided by 8, that will give us a decimal number. So what is the decimal number you get? 0.875. So what does a 0.87? What would be appropriate place to run this answer? Well, on the answer key, they get rid of this question because this is not a very good one. Because 7 out of 8, it is a decimal number, but it does not represent money. Because they see the money sign is already cancelled out. If this is a money, we'd better to run it for 2 digits to a cent. However, this 0.875, it is not a money. It's not a the unit is not a dollar. It's just a number 0.875. So this question is a wrong question. Please delete this. Okay, delete it. So we only need to answer as a decimal number. This ratio is 0.875. We don't have to run. Question C. Can we use a meaningful sentence to describe this ratio? Okay. Just come up with one meaningful sentence. Okay. Let me give you one example. Because the ratio is 7/8, we can write the meaningful sentence as what? For every $7 that Jane makes, how much does Lee make? Lee makes what? $8. So this is one way. Every $7 that Jane makes, Lee makes $8. This is a comparison, right? This is the ratio, right? So you can write another sentence, okay, is what? This 0.875 is what? 87.5%, right? So you can also say Jane makes what? 87.5% of what Lee does. Also fine. You don't have to do both. You don't have to. Just do what? Just one sentence. Or you can write another sentence. Because the decimal number it's the same thing as what? Per 1, right? So you can also say for every, okay, $0.875, Jane makes, Lee makes how much, guys? $1, yes. Either sentence works. You don't have to answer all of them, just make one sentence that you feel the most comfortable way, okay? But the idea is the same thing, comparison. For every something, the first people does, and then the second, people does what? So that's good, everybody, for this question. It is a very good question because it asks us to write the ratios in both of the fraction and also decimal form. Also, it asks us to use meaningful sentence to describe the ratio. So in your exam, you might encounter questions like, find a ratio, I found out the ratio in a fraction way or decimal way or something, and then write a meaningful sentence to it. So be prepared for this type of problem, okay? All right, so this is page 13, okay? Well, of course, for the rest of the questions on page 13, you have to, I want you to do them by yourself, okay? By yourself. Page 13, or 14, guys. I'm not going to give examples, okay, for you, because this chart on page 14, they have already give you an example, right? See, they've already give you an example when compare two different concepts, right? So compare apples with oranges. They don't have the same units, but we can still compare them, and then write them in the fraction, reduced fraction form, decimal form, and how to use meaningful sentence to write down the ratio. This is an example already, so I'm not going to redo another line for us in class. So I want you to finish up the other 3 lines by yourself in group. Okay, just mimic what is given from the first line, and you can do the rest part by yourself. You are, I believe. Okay. All right. So this is page 14. Now let's move on to page 15. Move on to page 15. For the ratios, we may have part-to-part ratio. We may have part-to-whole ratio. I'm going to have a volunteer read both of these two concepts for us, okay? Any volunteer? A gentleman, please.
Which part?
Just these two boxes.
Parts of part compares two things based upon the differences. Note all ratios seen in this lesson so far are parts of part. Parts of whole compares one thing to an entire lot. Note parts of whole ratios can also be expressed as percentages.
Okay, very good. So you have to know what's the difference between a part-to-part ratio and part-to-whole. Part-to-part ratio compare what? Two things based on their differences. So two different things comparison, okay, compares. Part-to-whole compares what? One thing to the entire what? Lot, okay, entire lot. And now here, it's important. Part-to-whole ratio can also be expressed as what? Percentage, okay? So, let's do one example, okay? The example 1, okay? Yeah, this example 1, let's do it. Okay, let's do it. So, same thing, I'm going to ask one volunteer read this example, the question for us, okay? Another volunteer, please. Everybody, please.
In a class of 26 students where there are 16 men and 10 women, the ratio of men to all students is 16 to 26. We could also say 16 out of 26 students are men, or about 61.5% of the students are men.
Can you also read these ABC 3 questions?
In the example above, what is the ratio of women to the whole class? Question A, write the ratio as fraction. B, can the ratio be written as a percentage? Explain your reasoning, and interpret the ratio using the meaningful sentence.
Very good. Thanks so much. Okay. So 16 men, 10 women in the class. What is the ratio of women to the whole class? How to write this ratio as a fraction, guys? How?
So 10 out of 26?
10 out of 26. Because the second quantity is a whole class, so it is 26. 10 out of 26. as a fraction, can we reduce it? If you want to, that's fine. If you don't want to, that's also fine. It doesn't say you have to reduce it. So 10 out of 26 gave us what? 5 out of 13. Right? Alright, can this ratio be written as a percentage? Yes or no? Yes. Because this ratio is a part to part or part to whole. What do you think about this ratio? Women compared to the whole class, is it part to part or part to whole? It's a part to whole, okay? Part to whole ratio can be expressed as percent, so yes. Okay, and then how can I get this percentage? Decimal form. The decimal form gives us the percentage, right? So 5 out of 30 in the decimal form is what? Use a calculator, please. What is 5 out of divided by 30? What do you get? 0.384. So let's run it. Yeah, 0.384. Yeah, we can do it this way. Well, some of you guys run it to 0.83, 0.38, right? 38, right? So either this or 0.838. It doesn't say you have to run to how many places, so it doesn't matter here, okay? Alright, so 0.834 in the percentage is what? 38.4%. Okay, you guys? So yes, why we can write it as a percentage? Because this ratio is what? It's a part to whole ratio, right? And yes. Number C, interpret the ratio using a meaningful sentence. Let's use this percentage to describe this ratio. We can say what? About 38.4% of the students are what? Women. Okay, so we can say about 38.4% of the students are what? Women. Or you can say the class, 38% of the class are women. Yeah, of the student, whatever. Okay, similar sentence. Okay. If you don't want to use a sentence, the percentage, this way to do the sentence, you can also say what? For every 5, out of the 13 students in the class, 5 of them are women, right? Or you say, for every 5 women, there are, compared to the entire class, okay? But usually, if we have a part to whole ratio, we have the percent. We prefer to use a percent way. This is more natural, okay? But you can also say every 5 women compared to the entire class. Everybody supposed good for this problem? Everyone? Question? Okay. Alright, so this is a part to part, part to whole. This is page 15. Now let's move on to page 18, I believe. It's about the age dependence ratio problem, okay? I'm going to give you a couple minutes to read this question by yourself, read this small table, and also read through this big table, okay? And answer the first, I would say, the first 3, yeah, you can answer the questions by yourself later, okay? I'll just give you 2 minutes to read this question and read these 2 tables by yourself, okay? Please. Have you done reading the two tables? Okay, let's talk about them, okay? So according to the U.S. Census Bureau for 2011, okay, so they are, they make, very detailed table about the populations by age and the sex, 2011, okay? Well, here, these numbers, okay, these total numbers for the population, the unit is what? 1,000, okay, in 1,000, means all of these numbers, okay, actually, they are what? 306,108,000. So actually it should be another 3 zeros after this number. So if we read it correctly, it should be the total number, the total population is 306,108,000 what? 1,000 people, okay? So make sure that in this table, this number looks small because they have already told us the unit is in 1,000. So after each of these numbers, there should be another 3 zero after each number, okay? All right, so these are in details about for each categories of the people, so what is the population. And this column gives us a percent, okay? So if in total the population is 100%, and then this gives us, under 5 years old, what is a percent of the people? 6.9%, something like that. Okay, so far we don't have to worry about that, okay? We don't have to, okay? We can just pay attention to these numbers, okay? So this is a detailed table, okay? And then, how about this smaller one? What's the relationship between these two? This is also your first question. You will answer this question later by yourself. What's the relationship? This table actually computed what?
Age groups?
Yeah, like a bigger categories. Say, kids under 14 years old, in total 62,155,000, okay? So they're adding up these numbers, right? And then they give us what? All of the kids under 14 years old, how many of them, right? And how do they come up with a 15 to 64 years old? They add up all of these numbers from 15 years old all the way to what? 64 years old, right? So they add up those numbers. And then how about the 65 and older? This number come from? Where does this one come from? Number come from? They add up all of the people who are 65 years and older. Okay, so actually this is a relationship between the two tables, okay? This is a more detailed table, this is a more condensed, table, more summarized table, okay? Okay, now let's answer question 5 directly. Question 5. Child dependency ratio is found by dividing the people under 15 by the 15 to 64 population. Is this part to part or part to whole? What do you think?
Part to part.
Why part to part? Yeah, under 15 years old and 15 to 64 years old. That's our two different categories, right? So they're different. It's not a whole. It's not a 40 years and under to the entire population, right? So this ratio is what? Part to part. Express the child dependency ratio as a decimal rounded to the 1,000th place. So how to find this ratio, guys? Ratio, we know, is a comparison of two quantities. By how to compute this ratio, guys? Dividing the under 15 by 15 to 64 population, right? So how do we do, guys? What do we do? We're going to use which number? 62,155,000, okay, divided by 204,775,000, right? So I'm gonna write it down here, okay? 65,155,000 divided by 204,775,000. Right? So please use your calculator, do the division, and give us a decimal number round to the thousandth place. That's why you need your calculator, right? What do you get? What decimal number do you get?
0.304
0.304. Everybody who has a calculator has the same answer?
or 303 if you.
Calculator, we do this. Oh, okay.
Okay, divide the wrong number.
You divide wrong number? Let's try, okay? 62155, okay, divide by, I skip the zeros, okay, because they both have the zeros, 204775. We get a 0.3035, blah, blah. We need to run it to the thousandth, right? So what? We should run up, right? We should run this 5 up. So that gives us a 0.304, right? So I'm going to write it here. It's going to be 0.0304. And then we know decimal number give us what? Well, can this number be a percentage? Percentage only works for what? Part to whole ratio. This is not a part to whole, it's a part to part. Okay, now the thing is, guys, for the next question, how can we use a meaningful sentence to describe the result of this ratio? Remember, decimal number always give us per one, right? Per one. So how to answer the next question, everyone? Oh yeah, number C. Write a meaningful sentence in interpreting your value from part B. How? We would say what? There is, okay, 0.304 children, or you can say people who are under 15 years old, whatever, okay, for every what? For every one, okay, working aged people, okay, or you say for everyone 15 to 64 years old to support, okay, working aged people, or say 15 to 64 years old. To support, okay, to support. So once we have the, okay, the decimal number we consider it is per one. So there's 0.384 children for every one 15 to 64-year-old to support. Or guys, remember if we compare two numbers, okay, this is point, a decimal number. If you do not want it, we can move the decimal point to the right for 3 digits, or you can write the answer as there are 304 children for every what? 1,000 15 to 64-year-old to support. Either way, okay? Yeah, make it to be consistent. If you use decimal number here, then you use 1. If you want to use integers, you say 304 for every 1,000, right? Because we multiply both of these two numbers by 1,000, right? So we get 004 to what? 1,000. Everybody? You guys? Okay, D, question D, how is this different from what it was calculated in number 4? Okay, we didn't do number 4, so we don't know. So after, you did the question number 4, you can come here to compute this, okay? Okay, so I think the specific questions, I'll, stop it at here, but there are some concepts that I want you guys to pay attention, okay? There is a child dependence ratio. It is computed by 50 years and older by the working age. Okay. Page 19. In the next question, you can do this by yourself. Okay. All dependence ratio. How might we compute this? All the dependence ratio. Think about it from the words and phrases. All the dependents. So how can we compute this ratio? How to do that? Should be what? Older people, which is 65 and older, right? Older people divide by what? Dependent. working age. Okay, so I'm just giving you a hint. Okay, how might we compute it? You're gonna answer this. Okay, you're gonna answer this question in a sentence. It's going to be people who are 65 years and older divided by what? 15 to 64 years old. That's the working age people, right? So old dependency. This is just a hint. And question 7, age dependency ratio. This is a third ratio you have to pay attention, okay, from this age dependency ratio problem. It's already told you it is computed by what? Age dependence means both of the younger people and older people together depend on what? Divide by what? Working age. Okay, so can you see how you compute this ratio? Add up the younger people and the senior people as a sum, compute as a sum on the top, and then divide by what? Working age. Okay, so try this problem by yourself. This is a hint. Okay, this is some idea for you. Okay. All right. Okay, I believe I have already covered the most important knowledge, information class material for you already. The rest of part of the class will be you do the problems that I assigned already. Okay, when you are done, let me check. If you want to leave in advance, fine. If you want to stay, fine. Okay. All right. I'm gonna stop.